All right, welcome to this explainer covering Module 5 of the AI and Automation Masterclass. We are officially moving away from the absolute chaos of manual inbox triage. Instead, we're building a fully automated algorithmic routing system. We're going to programmatically capture, parse, and route your inbound data in literally milliseconds.
So, here's our syllabus for today's explainer. We'll hit the automation paradigm, setting up inbound listeners, semantic parsing and extraction, database routing and archival, and wrap up with real-time alerting execution.
Part 1. The automation paradigm. Going from manual triage to algorithmic routing. Now, to frame exactly why we're building this, there's a recent framework paper that just hits the nail on the head. It states that manual email categorization, sorting, and classification has become a significant source of cognitive load and productivity loss. And honestly, it makes sense, right? On average, professionals receive hundreds of emails a day. Trying to manually filter out the noise just to find that one urgent project update is incredibly prone to human error.
So, the absolute crucial point here is that we need an event-driven workflow. Simply put, this is a system architecture where specific triggers, like, say, receiving an inbound email payload, automatically fire off a sequence of logic and notification nodes. No human intervention required. It's like setting up a digital domino effect. You build it once, and it just runs in the background.
And this is our end goal, a complete high-level blueprint. Think of it like this. An inbound email hits a server, which triggers an automation platform like NNN or Make.com. From there, it hits a large language model, or LLM for classification, in this specific case, the Anthropic Claude API, before pushing out to your logging modules and messaging APIs. We are going to tear this whole thing down node by node.
All right, Section 2, setting up inbound listeners. This is the engine of data ingestion.
The workflow always begins with a persistent connection to your mail server. Now, in the past, this meant using traditional IMAP polling, but IMAP has a massive flaw: UID instability. Basically, message sequence identifiers can actually change between sessions, meaning your automation might just lose track of what it has and hasn't processed. Total nightmare. So instead, we're using modern, highly stable API triggers, specifically Google Cloud OAuth webhooks. These securely extract raw metadata arrays like sender strings, timestamps, and body text. Now, if you're using an integration platform like Make.com, setting this up correctly is absolutely vital to avoid those constant, frustrating authorization errors. You actually have to go to the Google Cloud console, not your standard Gmail settings. First, you configure the OAuth consent screen. Then, set the application name to something like Make.com integration. Step 3, and listen up because this is where most people fail, you must input the exact redirect URIs provided by your automation platform, both with and without the trailing slash. Missing just one variation will literally cause the entire authentication to fail. Finally, submit it for production status verification so your tokens don't just expire every 7 days. And please, lock this into your memory. It is a critical setup rule that you must enable both the Gmail API and the Google Drive API for full functionality. Even if you think you're just processing emails, many of the underlying operations for handling file attachments actually rely on Drive infrastructure. Skipping the Drive API causes about 30% of automations to just fail silently behind the scenes.
Moving on to Section 3, semantic parsing and extraction. This is where we normalize unstructured text streams. So once the listener actually grabs the email, it sends the subject and body to a text pre-processing node. This normalizes the data before handing it over to the Anthropic Claude API. Claude basically acts as a semantic classifier here, intelligently reading the context of the email to figure out if it's urgent, a bill, or maybe just promotions. This is a real game changer because it prevents those annoying false positives where, marketing spam using the word urgent accidentally triggers a team-wide alarm.
After classification, you'll see the workflow physically branches into a conditional logic array. If Claude tags that JSON payload as urgent or high value, it gets mapped down a completely separate operational path from your standard, everyday inquiries.
But hey, we don't just want category tags, right? We want specific, actionable data points. Let's say a client emails saying, "Hello Raviya, we need a secure payment portal completed by next month. Our estimated initial budget allocation is $7,500. We use a text parser module with regular expressions, or Regex. By deploying a specific code syntax like $$$D+, the system scans that massive text body, pinpoints that exact budget integer, and extracts the output, 7500. This extracted value is now a perfectly clean variable we can use downstream.
All right, Section 4, Database Routing and Archival, Structuring Clean Metadata in Airtable.
If you're structuring this in a relational database like Airtable, linking multiple records to a single client can honestly be a bit tricky. A lot of users accidentally create exponential duplicate rows. To fix this linking architecture, you first utilize an iterator to process multiple account bundles. Then, pass that data through a text aggregator to compile the record IDs, making sure to use a comma as the separating value. When you finally hit the update module, you select manual mapping and apply the split function to accurately link those multiple records. It perfectly updates your operations metrics concurrently.
And here is a massive troubleshooting tip, an absolute Airtable routing rule. Ensure you are mapping the 17-character record ID, which always starts with the letters REC, and not the string value when you're updating linked cells. Mapping the string value is literally the #1 cause of database rejection errors. It'll save you hours of debugging for sure.
Finally, Section 5, Real-Time Alerting Execution, Triggering Immediate Microservices.
So if that $7,500 budget email comes in, triggering our high-value conditional logic path, we obviously want the sales team notified instantly. We achieve this programmatically using Slack. The implementation is super rapid. First, create a Slack app for your workspace. 2, activate incoming webhooks. 3, generate a unique webhook URL for your target channel. And 4, configure your automation to post a formatted JSON payload directly to that URL. That payload contains your parsed critical data, the sender, the budget, the whole shebang.
And why go through all this setup? Well, the beta testing data proves the ROI. By combining these API listeners, LLM classification, regex parsing, and webhook alerts, this architecture achieves 95% categorization accuracy. Even better, it pushes urgent notifications from the server straight to a user's device with less than 15 seconds of latency. It completely eliminates manual monitoring while actually supercharging your responsiveness. So, as we wrap up, my final question for you is this. How will you adapt this structural routing blueprint to automate the manual triage in your own custom microservices? The architecture is right there. Now it's up to you to build it. Thanks for joining me on this explainer, and I'll see you in the next module.